Hi everyone, so here we're going to talk about something called ions. This will actually set us up for how elements combine with one another to form ionic compounds. You'll need your notes and your reference tables. So we'll talk about what ions are, what trends there are with metals versus nonmetals, something called the Octet rule and exceptions to that, periodic trends, and polyatomic ions. So ions are pretty much atoms that have either gained or lost one of their valence electrons. And atoms will gain or lose some of their valence electrons in order to have a full outer shell, or a full valence shell. For most elements, a full valence shell would be 8 electrons. For hydrogen and helium, however, there's only 2 electrons that are able to be in their outer shell. Ones that have 8 valence electrons we call the octet rule. So metals and nonmetals each do different things. Here we look at metals first. They actually end up losing valence electrons. So we'll look at potassium on the lower left here. I've drawn this out for you already. If we notice, potassium should have 19 electrons, and they should have 4 principal energy levels. Their last energy level, or their last valence shell, will only have 1 valence electron. So if we get rid of this valence electron, that means that we're down to 8 valence electrons in its outer shell. That has fulfilled the octet rule. When this happens, these become positive. So let's just take a look. Potassium will have 19 protons, and an atom will have 19 electrons. So again, this is just for the atom. So overall, this should be a charge of 0 or neutral. However, ions will have still the 19 protons because we haven't changed the number of protons, and we won't unless we change the element completely. But this time we got rid of an electron, so we actually only have 18 electrons, so 18 negative charges. So this is a +1 charge. When we write this out, it actually ends up being K plus 1. So these are positive ions, and they're called cations. Now, some ways to remember a cation, if you notice that T, that forms a plus sign. So you remember that that's actually a positive ion. The ion or cations end up being smaller than the atom. Let's kind of erase this and go to the new version, essentially. So here we have the atom on the left-hand side and the cation, or the ion, on the right-hand side. So we notice that the atom has all full 19 electrons, 1 electron in its valence shell. The cation has only 18 electrons, and there's no electrons in the absolute outermost shell, so we actually end up showing that its next outermost shell has 8 electrons. So again, because of that, we actually see that since we kind of got rid of this last energy level, the size of the atom, or size of the ion, is actually smaller than the size of the atom. Alright, so this is what happens with metals. And funny little joke, think I lost an electron. Are you sure? I'm positive. So of course, use that little joke to help you remember that when you lose electrons, ions become positive. Alright, so here are nonmetals. When we use sulfur as our example here, these guys will actually gain electrons to have a full energy level. Now if we notice sulfur here, it should have the 16 electrons, and it has 8 valence electrons. So let's think about what would take more energy, to gain 2 more or to lose the 6 valence electrons that are in there. It takes less energy for this atom to gain 2 more electrons. When they gain electrons, they're called anions. They become negative, and we'll show you the sulfur ion. So here we have the same sulfur, but this time we're actually going to be gaining 2 more electrons. Now we have a full valence shell, or 8 electrons, to fulfill the octet rule. These end up being negative because they've gained 2 negative electrons. The anion ends up being a little bit larger than the atom because there's more electrons. There's going to be less attraction between the positive nucleus and those valence shells. One thing that is very important here that I want you to notice, that the name changes for any nonmetals. So, for example, instead of this being a sulfur ion, it's actually just called sulfide. We change that ER to an IDE. You've heard of the oxygen ion. That's actually oxide. If we had phosphorus, that would be phosphide, and so on. So these all will have an IDE ending. Anytime you see the IDE ending, note that it's going to be a nonmetal from the periodic table. And the exceptions to the octet rules. So again, the octet rules that we wanted to have, or ions will have 8 valence electrons, but hydrogen and helium can only have 2 valence electrons because they only have 1 energy level. So this is a hydrogen atom, and to the left of it, a hydrogen atom that's lost an electron. So note that it still has 1 proton. Let's see, let's go back through. 1 proton, but it has 0 electrons. So this will have a +1 charge. So we show this as being hydrogen +1. The next one we'll show on the right-hand side is actually if the hydrogen will gain an electron. So the hydrogen atom gains 1 electron. So here we still have 1 proton, but this time we have 2 electrons. So here this actually ends up being a -1 charge. So we can have H -1. Anytime we have that negative charge, an anion, we have to change the name of the ion. So instead of being hydrogen, this is now hydride, the IDE ending. This would still be hydrogen, but we'd call it hydrogen ion. You need to make sure the ion is in there. And this is just the hydrogen atom. So make sure you know the difference between the ion, the atom, and anytime it ends in IDE. Alright, so here's some periodic trends that you've seen before. I just want to make sure that we cover this again. Anything group 1 has 1 valence electron, and it's going to usually get rid of that 1 valence electron. Also, want to make sure, made another little note, more exceptions to the octet rule would be these guys as well. So you notice that lithium here will get rid of that 1 electron, and now it only has 2 valence electrons. That again is another exception to the octet rule. Same thing with beryllium. It'll get rid of those 2 valence electrons. It will now only have 2 more in the first shell. Boron will get rid of those 3, and now it's left with that first energy level, which has 2 valence electrons. And then group 4 atoms we'll talk about in just a bit. So any group 1 will be a +1 charge. Hydrogen is also an exception. It can also be a -1 charge. So a plus or a -1. Group 2, these are all metals, so these will be a +2 charge, so they'll get rid of their 2 valence electrons. Group 3 will be a +3 charge, because they'll get rid of their 3 valence electrons. 4 is when we get to be a little funnier, group 4A or group 14. So they have 4 valence electrons. They can either gain 4 more or get rid of those 4. So they can be a plus or a -4 charge. When we get over to 5A, or group 15, this is when we actually start gaining electrons. So nitrogen will end up being a -3 because it will gain 3 more electrons to fulfill the octet rule. Oxygen will be -2. In group 16 or 6A will be -2. The halogens, or group 7A or 17, will be -1. Now let's take a look at group 8A or 18, the noble gases. If you note, their valence shell is full, so they actually won't end up gaining any electrons or getting rid of any electrons. Some exceptions to this for group 18 or the noble gases, and you do need to write down these exceptions, so make sure you get those down, that the further down you go, like for example xenon, that might start to get rid of some valence electrons. The reason for that, and remember the whole reason electrons are here is that nucleus will be positive. It's holding in all of those negative electrons. Well, if we think about xenon, which is just a period below, it ends up having 5 shells, and then all of these electrons in the middle end up shielding the valence electron from the nucleus, meaning that the nucleus can't hold on to that valence electron very well because there's so many other electrons in the way. So once you get down further to the noble gases, they actually end up starting to lose some electrons. But that's usually one of the exceptions. We won't see that on our regions. You might hear about that in honors or AP. Some other ions we have are called polyatomic ions. These have more than one atom. That shouldn't be ion, that should be one atom. Or actually, let's make that element. So for example, and again this is all in table E, hydronium has a hydrogen and an oxygen. Mercury is one of those little weird exceptions, But ammonium has nitrogen and hydrogen. Acetate has carbon, hydrogen, oxygen, cyanide, carbon, nitrogen, and etc. So it's more than one element listed on these. You will need to memorize these, and I know it sounds silly to memorize them, but because they're listed on Table E for you, but I want you to recognize them. So, for example, these first three are the only cations that we have on Table E. They're not the only cations in the world, but I'm just showing you that those are the ones that are existing on Table E. The ones below, we actually end up all having anions for these. Some things I want you to note. Most of these end in like ate, ite, so eights and ites, and a few little ides. So if it ends in ate or ite, it comes from Table E. If it ends in IDE, well, remember, any nonmetal just by itself that's an ion will end in IDE. So you just have to make sure that you look. Okay, so if it's like phosphide, check on here if it's there. If it's not, then it's just the phosphorus ion. Some ways to help you remember this. So let me take a look at these two. There's carbonate and hydrogen carbonate. Let's look at the difference. The carbonate's CO3 minus 2. The hydrogen carbonate's HCO3 minus. Well, since we added a hydrogen will be a plus charge, so we actually end up becoming a little bit more positive. So it went from -2 to -1. Some other things here are the chlorates, so hypochlorite, chlorate, chlorate, and perchlorate. So if you notice that the hypo has only 1 oxygen, the ite has 2, the ate has 3, and the perchlorate has 4 oxygens. These all have the same -1 charge though. Some other examples, chromate versus dichromate. So chromate just has like 1 chromium and 4 oxygens versus dichromate, which has 2 chromiums and 7 oxygens. So that di is representing the 2 chromiums in there. Let's see, nitrate versus nitrate. Nitrate only has 2 oxygens, nitrate has 3. Let's see, and sulfate and all these sulfites. So sulfite has 3 oxygens, sulfate has 4. Hydrogen sulfate, you actually end up forming a hydrogen in there from that original sulfate. And then thiosulfate's just a little weird. It actually ends up being S2O3, so that actually ends up being 2 sulfurs in there. So one thing to remember, ate is bigger than ite, meaning that if there's anything that's an ate versus an ite, so for example these guys, let me actually erase some of this for you. These guys right here. So ate is bigger than ite, meaning ate has more oxygens than anything with an ite does. And you again will need to memorize, and we'll try to find some more little tricks to help you out with these. And let me show you a drawing of one of them. For example, ammonium. We have ammonium as NH4+. So it actually ends up having 1 nitrogen in the middle. And actually I'm going to give you a little shortcut right now. It's called a Lewis dot diagram. It just shows you the valence electrons. So let's think about how many valence electrons nitrogen has. It should have 5. 1, 2, 3, 4, and 5. And now I'm going to plug in the hydrogens in green. Hydrogen we know only has 1 valence electron, so we have 1 valence electron there, this valence electron, and this one. So we note that there should be 4 hydrogens. Where do we place them? Because now nitrogen has a full 8 valence electrons. So we can actually end up putting one right there, and because of that, 1 electron leaves. So since 1 electron leaves, the one that hydrogen was supposed to have, it actually ends up being a positive charge. So when we're looking at these polyatomic ions, they should have a little bit of a different structure than what we're used to. But I do want you to make sure that you do look at them. We'll evaluate or how to draw these a little bit later on too. So to summarize, metal atoms lose electrons, become positive cations. Their ions tend to be a little bit smaller than their atoms. Nonmetals will gain electrons to become negative anions, and those will be a little bit larger. And polyatomic ions have more than one element, and you can find them on Table E. Let me know if you guys have any questions. Have a good day.